Question 3. Here we want the coordinates of the function. The gradient is a key word, so we want to differentiate it. Multiply by the power, reduce the power by 1. It's the gradient that is 1.5, not x, so replace the gradient with 1.5 and solve for x. X equals 1. We're asked for the coordinates of the function, so put it into 1 into the equation to find out what the coordinates are. We want the surface area. I've got the surface area. We want a rate of change. A rate of change means we have to differentiate. So multiply by the power, reduce the power by 1. The side is 3 units, so put x equals 3. Pretty easy. This one here, we have the derivative function. We want to find the original function. We don't know what the constant is, so the graph could be anywhere. We've got a gradient of 3, so there's a line with a gradient of 3. We're not sure what it is at that particular point. Now that gradient of 3 could be anywhere. You could put it there, you could put it there. It doesn't matter where the line is, as long as it has a gradient of 3, but at the point x equals 0, it's a hollow function. We don't know what it is. Now the gradient on the right side, the gradient changes. It's 3, then it's 2, then it's 1, then it's 0, and negative 1. So what does that look like at 3? There's a gradient of 3, there's a gradient of 2, there's a gradient of 1, there's a gradient of 0. The key point would be the turning point. The turning point has to be somewhere where x equals 3. So I've done a sketch like that. Now let's match it up with the gradient. I haven't done very well actually. See, the gradient is not quite there. It should be 3, but it's only a sketch. It says sketch the graph, so it's good enough. I've got the right idea. It could be anywhere along there. So I'll go back and repeat those a bit. You could have your graph in any of those places where the gradient is 3, the gradient is 2, and the gradient is 1. Okay, so I'll just leave it there. That's relational thinking. This one here, we've got a rocket starts from rest, and how far does it travel in the 10th second? So we've got acceleration, we want distance. So from acceleration to velocity to distance, we have to anti-differentiate. We have to do it twice. We're going to change or expand the brackets out for the acceleration. For the velocity, write out your acceleration and add 1 to the power, divide by the new power, and add your constant. But because it's from rest, your constant is going to be 0. What do you do with that quarter and the 3? You multiply your denominators because t is being divided by the 3. So it's t cubed over 12 minus t. For the distance, you write out your velocity equation, add 1 to the power, divide by the new power, which means you'll multiply your denominators. Do the same for the t. Because it's at rest, the c will equal 0. Tidy it up a bit, that's your distance formula. Now we want the distance for the 10th second. The 10th second is when you start at 9 and go to 10. The first second is from 0 to 1. So we start at 9 and go to 10. So work out the distance for 9. Put 9 into the equation, it's 96.2. Work out your distance for 10. Put 10 into the equation, and it's 158.3. Find the difference between those, and you have the distance for that particular rocket there. That's excellence level. Now we want to find the maximum vertical distance. So the vertical distance is measured by the y. So what we're going to do is subtract these two y equations. So there's the first one, and I'm subtracting away the second one. Make sure you're careful with the negatives. It's minus 16x, which gives you negative 36x, and it's minus negative 10, which gives you positive 10, 17. We want the maximum. That means you're going to have to differentiate. Differentiate, multiply by the power, make it reduce the power by 1, then make it equal 0 because it's the maximum. Factorize, factorize again. You find that your x values are negative 3 and 1. Now, which is a maximum, which is a minimum? You've got a cubic function. And if you go along the x-axis, the maximum comes first, so negative 3 will be your maximum, 1 will be your minimum. So you put negative 3 into the equation, and you work out the distance is 125 meters. Now if you wanted to show off, you could have double differentiated to show that negative 3 was negative, so therefore is a maximum. So that's the calculus way of showing that it is a maximum.